Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic equations, specifically how to write them in both standard form and vertex form, and we will do it in 5 minutes or less. So our standard form for quadratic equations is right up here, and sometimes we will be given an equation here in vertex form, and we'll need to transfer it from one form to the other. And vertex form, remember, is very useful because if you can get an equation in that form, you know that the vertex is going to be the xy coordinates of the h and the k. So how do we get from this vertex form up to a standard form? Well, really, all we want to do is we just want to FOIL this out, right? So let's take a look at it this way. This x minus 3 squared is really x minus 3 and then x minus 3. That's what x minus 3 squared equals. We just need to simplify. And when we do that, right, we do the FOIL, the first, outer, inner, last. So the two firsts, right, is going to be x squared. And then the outer, x and the minus 3, that's minus 3x. The inner, that's another minus 3x. And then the last, minus 3 times minus 3, that's going to be plus 9 minus 4. Now we simplify. Y equals 3x squared. We're going to distribute this out. I've got a minus 6x. So I'm going to multiply that by 3. That's minus 18x. And then we have 3 times that 9 plus 27 minus 4. We're almost done. We simply need to combine these like terms. And here is our standard form. Same parabola, quadratic function there, but it's going to be a plus 23. Let's look at a different example. Sometimes you'll be given just the coordinates of the vertex and one point that it passes through, and that's all we need to write both of these equations here. So remember, our vertex in this vertex form is the h as the x-coordinate and the k as the y-coordinate. So if we have a vertex, we have the h and the k. If we have a point that it passes through, we at least have an x and a y that's going to satisfy this. So we can actually use this vertex form here. Let's plug in our -1 for the y, because really the a is what we're missing, and that's what we're searching for. And for this case, our 0 is going to be our x. Our h, remember, is the x-coordinate of our vertex. And then our k is the y-coordinate of our vertex. We're just going to solve for a. 0 minus 6, that's just going to be -6 squared plus 17. So that's going to be 36a plus 17. Let's subtract 17 from both sides. Isolate this a here. That's going to be 36a equals -18. And all we need to do is divide both sides by 36. And look at this. We get a equals -1/2. Now we're not done yet because we need to rewrite it here. So in our vertex form, we're going to say y equals, now we know our a. We're going to leave our x and our y just as x and y, but we do want the vertex in there. So it's going to be minus our vertex has 6 in the x-coordinate squared plus, and then our k is the y-coordinate of the vertex, that's our 17. That's how we'd write this in vertex form. How do we write this in standard form? Well, we just do the same thing we did last time, is we just simplify this out. We FOIL this out. So this is going to be y equals -1/2, and really this is 6 minus x. 6 minus x, we'll deal with the 17 later. And then we're just going to FOIL this. So that's going to be the first, x squared. The outer, that's a -6x. The inner, another -6x. Last, plus 36. And then we get that plus 17 we'll bring back in there. So simplify like terms. We're going to get an x squared minus 12x plus 36. We're going to need to take a -1/2 from all of that. So -1/2 x squared. That's going to be a positive 6x. That's going to be a minus 18 if I distribute this out like that. And that's going to be a plus 17. All we need to do is simplify those two. We get y equals -1/2 x squared plus 6x minus 1.